Hey guys, we are going to be starting science, and how we're going to do this is we're going to designate one day. Basically, one lesson is going to span 2 days. One day we will read and just solely read. I will read it and explain some of it to you, and then the next day you are going to answer a few questions with what you've read. So here's how it's going to work. Today I'm going to read chapter 1, and then after you get done listening, I would like for you to read it to yourself, or at least read it to an adult or someone at your home who's going to listen and pay attention and know if you're, getting the words right or wrong. So do that for me on Monday, and then Tuesday you're going to answer 12 questions. Now, we're in science. We're going to start in earth science, and we're going to be doing the earth's shifting pieces. Now, here's the big question, and be ready to answer the big question. All right, I'm going to send a kind of like a Google Doc to you so you can type out your answer to the big question. Okay, why are some fossils of the same type found thousands of miles apart on different continents? So, why is it that paleontologists find fossils from the exact same species of animal in two different continents? So, the vocabulary words that we're going to need to know. Sorry.
All right, it is almost 5:25. Teachers, if you will
So
wrap
we're
up
going
what
to
you
do
are
some
doing
vocabulary.
and
We
calmly,
have fossil,
carefully
which is a
walk
noun.
your students into the
It's the
lobby. We will
remains
line
of an
up
organism
to go
preserved
home.
in rock form.
Let's try and get down here in the next 5 minutes. 5 minutes before we all go
Sorry,
home.
this is the third time I've started this video. I'm not starting again. Okay, and geologist, which is a noun. It's a scientist who studies what Earth is made of and how it changes over time. Okay, so the Earth's shifting pieces. The eastern coast of South America contains a fossil of a reptile that lived hundreds of millions of years ago. Fossils of the same reptile can be found 5,000 miles away in Africa. Just to give you an idea, here's a globe. Okay. Woo. Okay. Now, trying to hold this and look at it, it's not as easy as it was initially thought of. All right, here is South America. And it said the eastern coast, right? Yes. So the eastern coast is on this side of Africa. Now, they said that the paleontologist or whoever found a reptile fossil over here. Now, they found that same exact fossil all the way across the water into the continent of Africa. How is that possible that I have one here, the same thing all the way, or the same species all the way over here? That's across the Atlantic Ocean and some of the Southern Ocean. How can that happen? Well, we're going to find out. And I got to find a place to put my globe here. Okay, if you hear a big bang, it's because the globe fell. Okay, geologists are scientists who study the earth, including rocks and fossils of extinct organisms. Extinct is a word that you need to know. Extinct means they're no longer existent. They do not exist. So, they study fossils of extinct organisms. Geologists found an interesting pattern when they looked at particular kinds of fossils. These fossils are discovered far apart across oceans. These animals couldn't have traveled the thousands of miles that now separate their fossils. This presented geologists with a problem. Why are some fossils of the same kind of organism found thousands of miles apart in different continents? That's our big question. So we have to pay attention to see if we can answer this. We can, we just got to pay attention. So the Mesosaurus was a reptile that lived long ago. Its fossil has been found in both South America and Africa. Because of that, this gave scientists a puzzle. Scientists love to figure out puzzles. So this is something they could do. So let's find out how fossils of this Mesosaurus can be found on both South America and Africa? Okay, number 1, we have the continental drift. Let me pull this up. Alfred Wagner provided a possible answer to the fossil evidence. He was a scientist who noticed how some of the continents appeared to fit together. Could the continents once have been close together and then moved apart? Wagner gathered evidence that supported the idea, which he called the continental drift. One type of evidence used to support his theory was the fossil record. After studying the fossil record, Wagner concluded that these continents had once been clustered together. Wagner's theory was incomplete, but it was the beginning of the study of Earth's plates and how they have changed over time. So, some of Alfred's ideas was that they kind of interlock together, kind of like what they known as Pangea, is that they fit together, and then over time the continents drifted apart. So that was his theory. Okay, that's a theory, couldn't be proven. So just like this is how he came up with it. So this is kind of like a picture, and you can say right here, look at the east side of South Africa and the west side of Africa on the world map. Why do you think the two coasts appear to fit together like two pieces of a puzzle? So that is what Mr. Wagner thought. Okay, he's like, okay, let's look at this. These pieces can be, manipulated to fit together. So that was his idea. And this was some of the evidence that he tried to use to prove his point. So the fossil of the remains of a I do not know, let's call it the cyno, an extinct land reptile approximately 3 meters long. So they found it in parts of South America, and then they found it over here in Central Africa. How is that possible? We have fossil remains of the freshwater reptile, the Mesosaurus, at the tip of South America and over here at the tip of Africa. 2 different continents. Fossils of the fern Glossophrydus. We'll just call it the Glosso. Found in all the southern. Look at this. It's in South America, Africa, India, even Antarctica, and Australia. Can you think about finding a fossil in Antarctica? That's weird. And then we have the fossil of the Lysosauros, and it's in 3 continents. 1, 2, 3. I don't know what that is. That piece of land right there. So it's found in Antarctica, India, and parts of Central Africa. So these were some of the ideas that he used to support his theory. Okay, so the Earth's crust. So vocabulary word that we need to know in the Earth's crust is a plate, and a plate is, in geology, it's a large fragment of the Earth's crust and the upper mantle. That's a plate. It's not like what you eat out of. This is a big, giant fragment of Earth's crust. Scientists now know that the Earth's crust are made of different pieces called plates. These plates move and interact over large spans of space and time. Sometimes it is obvious when the plates' moves occur, such as if a group of islands pop up out of the sea after an earthquake. Most of the time, though, the movement of the plates happens so slowly to notice. And when we do notice them, we have what's called, you have different type of plates. You have, you have converging. When they converge, that's when you're going to get your mountains and stuff like that. You have diverging, which is where you get your volcanoes and everything else. And then you have the shifting. This is where you get your earthquakes. So when plates move, they move together in a couple of ways. They either converge, when they go this, or like they'll slip under each other. They diverge, they come apart, and that's how you get your volcanoes. Or they shift like this, and that's how you get earthquakes. So the world itself is made up of several different plates. And one of the most, I'm going to bring this out because I'll just show you both times. Okay, so you have the Pacific Ocean right here. Okay, it's pretty big. Okay, now in the Pacific Ocean, between the Asias and America, okay, that's a place that we need to talk about just real quick. So this right here, this area we have like in Australia, up through here, up along Alaska, down through the Canada, California, down through Mexico. This is called, in this area right here, is called the Ring of Fire because it's very active. These plates that they're on are very active. Now, some plates are larger than others, and that's just how the plates are done. That's how they broke apart. But what these plates are doing is they're kind of, I'll let y'all see like this. Just pretend it's flat. They're like kind of like, just like doing this. They just sit there and they're actually floating on magma. It's kind of what they're doing. Just imagine like that. It's kind of like when the floor is lava, you have stuff that's floating. That's what it is, kind of. Just to give you a visual. And what happens is these plates, okay, when they move, like I said, they're either going to move apart, diverge, they're going to converge, or they're going to shift. And sometimes they do it so slowly that we don't even feel it. But sometimes it happens so suddenly that we do feel it. And that's when you have your earthquakes. Can geologists observe and measure plate movements? They can. One such tool is the Global Positioning System, or GPS. GPS receivers are placed on different plates. They communicate with satellites that orbit Earth. The system locates each receiver and measures the distance between them. Scientists use this data to measure the changes in the distance between the receivers. So that's how they measure how plates move. So, why exactly do plates move? Well, like I said, they are sitting on top of something. They have liquid rock. It's actually liquid rock that is below the Earth's surface, and it's known as magma. It is very hot. The layer of earth where magmas form is called the mantle. So you have the crust, the mantle, and the core. Crust, mantle, and core. Beneath the mantle lies the Earth's core. The core has two layers, the outer core and the inner core. The outer core is more molten than the inner core. That means it's more like solidified or more liquidy looking. But both layers of the core are made mostly of iron and nickel. These are two very common elements that we have here on Earth. The core is very, very hot. Okay? It is up to 10,800 degrees Fahrenheit. That is almost as hot as the surface of the sun. Now, the intense heat of the Earth's core plus the pressure from above, the pressure from gravity and stuff, produces currents in the mantle. These currents help transport the plates across Earth's surface. This helps explain how land masses and fossils that once were located close together can be found thousands of miles apart. The movement of plates is one process that shaped the Earth. Now, I believe we just found the answer to the big question, if you were paying attention. Now, that is all for lesson 1. But here's another word you need to know. Molten. Molten means liquefied. It is usually used to describe liquefied substance that would be normally solid, like you said, liquefied rock. And it usually describes metals and glasses and rocks. So this was a section on our lesson about the movement of the earth and why, it shifts and stuff. So we need to know this right here. Okay. Study that and just look over your vocabulary words and please read this to yourself. And if you want to, read it to somebody else. And then we're going to go over and then you're going to answer some of the questions. Okay. If you want to, you can actually go ahead and answer maybe the first 6, and then we can do the last 6 tomorrow. It's up to you. But please make sure that you're doing this the best you can, that you're writing neatly, because I do not know which one, but I'm just going to pick a page out of the packet and it will be a grade for your science. And we need to get our science grades up, okay? So, good luck, best wishes, and we are good to go.